Hello, everyone. In this episode, we feature a talk given by Dr. Jaclyn Ocumpaugh titled Affect Detection: Finding Emotions to Support Learning. Dr. Ocumpaugh is the Associate Director of the Penn Center for Learning Analytics at the University of Pennsylvania and part of the editorial board for the Journal of Learning Analytics and Computer-Based Learning in Context. Her talk covers some of the methods used to generate models that detect student affect when sensor data is impractical or altogether impossible. The talk concludes with a discussion on how these models have been used to explore the relationship between student affect and learning in different contexts. Attending this talk made us feel a lot smarter and more accurately informed about affect detection and its implications to learning. We hope you would feel the same way. Please enjoy.
Okay, so the title of my talk today is Affect Detection: Finding Emotions to Support Learning. And we're going to talk about a few things today. I do want to say thank you again for coming, especially given everything that the world is going through at the moment. I have managed to successfully avoid all but minor tropical storms in my life, but I definitely understand we're on, I think, our 29th storm in the US this year, so I know that's a lot to go through right now. We're going to cover basically four things today. So we're going to talk a little bit about what emotions and affect are, and why they're important, particularly for learning. And then we'll talk about how to model them or detect them. And there's a few different ways. I will talk less about sensors. I'll discuss the kinds of sensors that there are, and then I'll talk about a technique that you may have heard of called BROMP and how we use it to model emotions from log files. And then we'll talk about what we've learned from being able to have this kind of data during learning, and whether or not the theories that we have are currently taking care of the kind of information that we're seeing from the empirical data. Okay. So emotions and affect are sometimes used interchangeably. There's a big block of text here. All of it is taken directly from someone who's trying to tease it apart. Essentially, emotions are the body's reactions to any kind of perceptual experience. And when you appraise them, effectively they become affect, right? So any of the cognitive processes or feelings that are aroused by the body emotions are typically labeled as affect by people that make that distinction. Not everybody does. The more lasting consequences are usually referred to as mood. But all of these things interact with one another and can play a role basically in concert. There are a lot of different theories about which emotions we should be paying attention to, and a lot of theorists are really concerned with identifying what they consider to be basic emotions. Some of them think that these basic emotions are universal because they believe that they are rooted in that bodily reaction. Plutarch believes that emotions are really heavily tied to overt behaviors that we can see. There may be some truth to this. There's definitely been a lot of attempts to try to classify them accordingly, right? There are probably, and I'll make sure that you guys have these slides, at least a dozen different theories on what the basic emotions are. And it looks like they don't really overlap. But if you look a little more closely, things like anger and rage, while they have different labels, are probably referring to the same kinds of emotions. And so there may be some really important things to look at in this literature, but these aren't necessarily the emotions that are relevant to learning contexts. So book that's come out recently that's actually written for a more popular audience, but has an incredible library of footnotes and resources attached to it, is How Emotions Are Made. And Lisa Feldman Barrett's a neurologist that's actually looked at a lot of the neuroscience research that's related to emotions. And she says that emotions are stochastically generated through interoception. So basically your brain has to perceive all these bodily things and then associate them with different experiences that you've already had. And so you make predictions about what the experience means that you're having in your body. And that helps you to understand what's happening around you. This is very compatible with sort of, if you know Vygotsky schema theory and constructivism in education. It suggests that emotions may vary slightly across cultures, even if there are bodily reactions to them, because different cultures expect different kinds of behaviors depending on different contexts. And she says that basically emotions can only be modified either with reappraisal, so you teach the person to reinterpret something like anger as excitement, or through distractions, so you give them something new to pay attention to. She emphasizes the importance of emotional granularity and points to research that shows that children with richer emotion vocabularies do better in school, right? So the more names that you have for the emotions, the more you can sort of control your experience, basically. And this is something that we've seen definitely during the COVID era. The social emotional learning is not necessarily the same as the kind of affective measurement stuff that we're doing. There's a whole lot of other kinds of mood and emotional experiences that they're worried about that aren't necessarily related to learning. But what we've seen in the research is that you're getting all of these different sources of feedback, and you have to figure out what's relevant to the context that you're in. And for a long time, people thought attention worked like a spotlight, but more and more they're thinking that attention works a little more like a filter, and that your emotional responses help you to filter through and figure out what you should be paying attention to. Okay. Within the context of learning, one of the major theories on affect is DeMello and Gracer's theory of affect dynamics. And essentially, this is the model that everybody cites. It's not the only model in their article, but he says that engagement or flow alternates with confusion, confusion alternates with frustration, and frustration alternates with boredom. But the path from engaged concentration to boredom would have to go through confusion, frustration. Okay. This is, again, what everybody cites. This was actually his original proposal, and it included a couple of more categories. So here you see there's actually two routes to confusion. So you can either, if there's extreme novelty, go through surprise to get to confusion, or you can go straight to it. And then once the confusion is experienced, sometimes you pass through delight if it was particularly frustrating. And it looks like I didn't get those arrows cleaned up. But sometimes you just go straight back to engaged concentration, depending on what kind of stimuli you've been exposed to. If that confusion doesn't resolve, then he says eventually students become frustrated and then they become bored, right? But we see that there are actually a lot of other pathways that may be there. And when we get to the empirical research, we'll talk a little bit about which ones are actually showing up, whether it's the ones in gray that DeMello and Gracer hypothesized, or whether it's some of the ones that we see here in this golden color that are hypothesized, but that maybe we need to be considering. So to go about modeling affect, there's a lot of different ways that you can approach it. We know that you can detect affect with sensors, and facial recognition is becoming a little more feasible. We definitely We definitely have everybody in front of computers in this country right now, or at least a lot of students in front of computers right now, and a lot of those webcams might be usable if conditions are correct, like if the lighting is good, if everything's been calibrated so that it works across different races, because we definitely know eye shape and skin color can interfere with these things. We could get some information out of skin conductance sensors, heart rate sensors, posture sensors. Those might be a little more difficult in the COVID era where everybody's at home, but they've worked in classrooms. This is a little more invasive. The EKGs and the fMRIs, they're a little harder to take into a classroom. We could send a bunch of graduate students or a couple of postdocs into a classroom. There are a large variety of different methods that we could use for sensors. And in fact, early research really has done a great job at detecting some of these through combinations of these sensors. Usually, the video sensors, the facial recognition stuff, can be fairly robust as long as nobody's chewing gum or turning their head or talking to their neighbor. And so often what we see is that you actually need more than one of these, even with the most robust sensors, to get really, really good data. But you can get balance, which is really important. So whether or not the kid is happy or sad, and that can be fairly predictive. The problem is that, sensors are difficult to scale. So some of these historically have been very expensive. And if you need to take them into classrooms and spread that across lots of students in lots of different schools, then that adds up very quickly, and you're depending on the schools to be able to implement these. We also see that even college students can be fairly destructive with these things. Or my favorite is you go into classrooms and you watch the kid take the laptop and play with it, and it just destroys any calibration of any kind of video that you have going on, right? So we have an alternative approach, and that's to actually use the log files of students and classroom observations. Those are a little more difficult to obtain during COVID, but once they're obtained, we can apply them retrospectively. So they're really nice in that, if you're just using the students' interaction data, their traces in the log files, then you have something that's fairly unobtrusive, and you don't necessarily have to wait for a long time to be able to collect enough data like you might have to with, say, like the heart rate information if you need baseline information. It might be a little while before you have enough to actually effectively know what's happening for that particular student. Okay. So early research on this worked on both affect and disengaged behaviors. The Baker et al. 2012 article was the first one to get cross-validated detectors of affect related to learning. Okay. So there were a few others that tried to get confusion or boredom, but they didn't. Their techniques in the statistical process didn't cross-validate, and that means that there could be some issues with generalizability. Okay. So we'll talk a little bit about BROMP, which you may have heard of before. So the Baker-Rodrigo-Ocumpaugh monitoring protocol, which is observations of student engagement. And for this, we include both behavioral engagement measures and affective engagement measures. These are made simultaneously, but separately. And I'll talk about how that works in just a second. BROMP has now been adapted to 7 different countries, and Germany is on the way. So we're about to have 8 different countries. And every time we adapt this, we go in and actually work with people who are native to the community so that we're not imposing in a more colonial way than we have to categories that are important. Right? So one of the things that we realized going into India was that frustration is not a socially acceptable emotion to display. And so that's not something that students would show. If I understand correctly, because I wasn't actually part of this process, that it's considered to be fairly babyish and immature, right? But it is socially acceptable, particularly for older students, to express contempt. And so it's a fairly similar emotion, but distinct from what we've coded in the United States and elsewhere. So when we go into classrooms, once we've established a coding scheme and we've made sure that the coders are trained, what we're going to do is code for behavior, right? And you should be able to see bottom left here, we have typical coding categories that include on task and off task, but also on task conversation, which means that the child is speaking either with a teacher or with a peer about the subject at hand. The dollar sign there is the symbol that we use for gaming the system, right? And then we have a question mark. And in recent versions, we've actually also added a skip button so that if the student is up and out of the room, we're actually distinguishing between the kids who can't be coded because we don't know exactly what behavior they're displaying. Sometimes it's ambiguous, although usually the behavior is a little more clear-cut than the affect. But definitely, like, we want to distinguish between a kid who's off task and a kid whose pencil is broken and they legitimately need to get up and sharpen it, or they have to go to the bathroom. These are not things that we're trying to predict. We want to make sure that we're only categorizing things that are truly off task as off task. Right? And then the affective categories, we have boredom, confusion, concentrating, frustration, and again, that question mark. Some of these coding schemes also include delight. We've had a few other affective categories that looked relevant over the years, so we can modify this if we need to. But what we're going to do is for each student, we're going to look at them and we're going to select one of those from each drop-down menus. We're going to record the first thing we see. So when we go into a classroom, if you can read these numbers here, right, we start with number 1 and we move around the classroom, entering in the student information so that it's saved in the app that we use to make these recordings. HEART here is stands for the Human Affect Recording Tool, and it's the app that I've shown you guys in the picture here before. This is a handy app for a lot of reasons. One of them is that it's very, very good at saving our data. So even when we've had, say, batteries fall out of the back of the phone, everything saves in a way that data that's been collected is protected. But it also just saves a lot of time and makes sure that we're automatically timestamping every single observation. So when we go into the field, we actually synchronize to NTP time. We send a little ping. We can choose to skip that step, but it gives us a very, very precise measure of when each observation took place. With errors, we assume that they could be off by as much as 2 seconds, but the actual log files show these things in fractions of a millisecond, and so very, very, very precise. Right? And then, like I said, we start with student number 1. We input on task and concentrating, depending on what we've seen. We go on to student number 2, who might be gaming the system and frustrated, and student number 3, who's on task and concentrating. Once we've finished all of this, we have a file in the app that we can actually mail out or harvest from the phone in other ways that includes all of the information about where we were that day, the timestamps, who was coding, and then you see the student information here, along with the offset time from the original timestamp at the top of the file and the codes that we've given for each observation. We take these back to the lab and we synchronize these observations. We know that the observations can take up to 20 seconds. After that, we tell people it's time to move on, just code the question marks. And so we start by labeling log files with clips that end at the timestamp of each observation. Okay. And usually we start with a 20-second clip and we try to harvest as many features as we can out of that clip, right? So when we distill these features from the log files, we're looking for semantic details of the action. So are they asking for help? Are they getting correct answers? Are they giving incorrect answers? Are they taking a long time to do it? We might look at assessments and predictions of the student's knowledge or skills. So Bayesian knowledge tracing information, have they mastered this material? And then again, the speed of the action relative to other students or to the student's other experiences in the software might also be important information. Once the features have been developed, we're going to go through a feature selection process. And basically what we want to do here is reduce the feature space by eliminating things that are co-correlated. And that ensures that we're getting measures with multiple dimensions. And so we've got the most robust types of measurements possible, and we pick the strongest performing feature on each dimension. We then test a number of algorithms, and our lab has some favorites, but there's others out there that probably work just as well. We tend to like very simple ones, just because they're easier to apply later if that's what you want to do. But we want to make sure that we're going through either a completely held out test set or a k-fold cross-validation. And basically, k-fold means that you take one, if you had sort of 5 piles of clips, you take one pile of clips on the first try and you hold it out and you train to figure out which feature performs best in predicting whatever your outcome is on these 4 training ones, and then you test on the 5th fold. And then the next round, you take a different pile of clips, right? And you train on the gray ones here, but it's a separate set of training, and you move on and move on and move on and move on. Once you've gone through this feature selection process, you do want to check performance, and really basic performance measures might be specificity or sensitivity. In our lab, we tend to use Cohen's kappa or A prime as well. And this just gives you an idea of why we would go through that, right? So again, this is just using accuracy as a measure, and that's not what you should be using. You should be using one of those other metrics. But say that you have an algorithm that performs really well on the original test set, but when you go through cross-validation, its validity decreases significantly. What this says is that there are students in there that probably are behaving differently than you expected, and that the model doesn't account for that very well, right? As you get down here, where they're a little closer to each other, but they're still both performing pretty well, right? Then you probably have more likelihood of subpopulations that need to be accounted for. But as things decrease, you may just not have the right number of features. And so you look at sort of these relative performances between a cross-validated model and a not cross-validated model as indicators of whether or not you need to keep moving in your feature design process, or you need to test different algorithms and move on accordingly. Once you've developed these, then we can start to look at what things that they can predict. And our lab has done this work now for more than a dozen software systems, and there's a wide variety of research out there. The one that we've done the most work with, though, is assessments. And so we were able to take assessments data and apply the affect detection to the retrospectively. So we had kids who were going into high school when we started a project, and we applied it to their 4th grade data. And we were able to predict their survey performances on survey constructs of interest and self-efficacy in their senior year of high school. We then went on to predict whether or not they went to college. So San Pedro et al., former Ateneo graduate, helped us with this model. And we show, the confusion and boredom are the 2 affective states here, and they're not the only things that are predictive of college enrollment, but they're actually fairly predictive of college enrollment, right? So carelessness and knowledge and the percent correct also turn out to be fairly important. But we were able to get 70 to 80% accuracy on who goes to college without any demographic variables at all, which is typically unheard of in the US. Socioeconomic status and other demographic variables are highly predictive of college attendance. And so if we're able to add to that discussion and give something that's a little more concrete for teachers to act upon, there's some potential here for really designing interventions to help students. Right? We've also looked at very short sequences of affect. So here we have N for basically any other affect besides confusion and frustration, and the X for the confusion or the frustration. And we see that confusion is not very correlated with learning gains. It was actually correlated with pre and post test, but not particularly with learning gains. The bold-faced here is significant at the 0.01 level, and then 0.05 is italicized. But what we see is if there's no confusion or frustration present, then we have sort of negative impacts on learning. If it's present even just a little bit, then we have positive impacts on learning. But as it increases, those go away. And we have non-significant patterns here. So what does this mean for the models that are here? So we've gone and looked for the different transitions that were hypothesized in DeMello and Gracer. And again, this was the original hypothesized theoretical model. The model that he ended up with after presenting his own empirical data was the one that's shown just here in gray, or the tiny version up here at top. If you look at the empirical data in his own study, though, what you see is there's fairly weak evidence. So there were 2 studies, right? And both of them were significant for this cycle. Both of them were significant for this half of the second cycle. Only one of them was significant for this half of the third cycle. This one, both were significant. This one, neither were significant. And then he also found a significant relationship in one of the studies between frustration and engaged concentration. So it doesn't fully match even his own empirical data. So recently, in fact, we presented this in the Philippines just a couple years ago. We started to go through other studies. So we looked at which studies looked at which affective states, and you see some of them included, anger, disgust, sadness, eureka, things that are not necessarily in the categories that we typically include in Bromp observations. And then we looked at all of the different contextual information in these studies. So some of them were conducted in the US, and some of them were conducted in the Philippines. Some of them were with older students, some of them with younger students. There were some in classrooms, some in laboratories. But one of the things that we were really concerned about was there could be sort of sampling issues. And in particular, what you see is, if we're observing every 5 seconds and engaged concentration continues for a longer period of time, typically than, say, surprise, we're much more likely to miss something like surprise if the sampling is short. But beyond that, if you look at DeMello's methods, for the most part, he actually removes anything that he would call a self-transition. So this change from the engaged to engaged or from bored to bored would get removed in that process before he looked at the metrics that he used to determine whether or not the transition is more or less likely. And the metric that he uses is usually referred to as Demelos L. He calls it a likelihood prediction. I've had a few statisticians sort of wrinkle their nose that it's not actually a true likelihood. They have some opinions about how that term should be used. But there's also some concerns about the way that it's implemented. And so we have a very clever student that discovered that there were some contexts where it was actually highly inappropriate to implement it the way it is. She's got a recommendation for a new formula that you can use instead. I won't go into those details, but we took this newer version of the formula that doesn't break in the same way that the likelihood one does, and we applied it to previous data, and we just compared it to what the data looks like in other studies, right? So again, here's one of DeMello's papers from 2013, and we see that 1, 2, 3 of the cycles he predicted are significant, but 3 others aren't. And we have an extra one here that wasn't predicted that shows up as statistically significant as well. Right? In his 2017 article, we do slightly better. So 2 complete cycles, and then this third one only has the first half from frustration to boredom. This one is not significant from boredom to frustration. Instead, you're more likely to see boredom return back to engaged concentration. This is an article that I worked on that was looking at West Point cadets. We found here this full cycle is statistically significant, right? This one is not. This one, the top half, is not statistically significant. Then this one, this is below chance, so statistically less likely to occur than other cycles, not just not significant. And then again, we have a couple of cycles here that are significant as well, but not predicted by the model. Okay. This one also does not bode well. Right? The only one predicted in the DeMello model is showing up below chance. The only one that is statistically significant. Right? The self-transitions are more important. And then the Karambaya data, we tried it with self-transitions because that's what our lab had historically done. And again, we found 2 halves of 2 cycles to be statistically above chance, but very, very weakly. And then the third cycle that was predicted here is occurring below chance, as are all these others. So the self-transitions are much more likely. So we were like, well, maybe it is the fact that we're including the self-transitions. So we tried it without, and we only fared slightly better. We did get this cycle to be statistically significantly above chance, but we lost these 2 here that had previously been statistically significant, and instead found that these other cycles were much more likely to occur, although at least a couple of them are fairly weak, so 0.03 and 0.09 versus 0.56 and 0.47. Okay. So just to summarize, right, if the first cycle here is A, B, C at the top here, DeMello and Gracer found evidence for that in both of their experiments, but we found statistical significance that was below chance if self transitions were included, it went above chance when they were removed. For cycle B, which is the cycle between confusion and frustration, they found statistical evidence for it for the first half of it, so from the confusion to the frustration, as did we when self transitions were included. Without self transitions, we found evidence against the return from frustration to confusion, and none of us found any evidence for the return in any of the other conditions, right? And then the loop from frustration to boredom and back, they found evidence in one of their experiments for the first half of it, as did we. And they found evidence for the second half of it, back from boredom to frustration, but we weren't able to find it in either one of our conditions. Right? So our conclusions in that paper, right, are that the hypothesized model patterns aren't being found very frequently. That doesn't mean that they're not correlated with learning. And in fact, we have actually seen that even though that full cycle is really, really rare when we've looked at more complicated sequences, that it is often predictive. So if you have a student go all the way from engaged concentration to confusion to frustration to boredom, and we are able to find that full cycle in their data in that order, then we see lowered learning. And conversely, if we see the cycle from engaged concentration to confusion to engaged concentration, we're more likely to see improved learning, even though that is, again, a fairly infrequent cycle overall. We hoped that the methodological differences, like including or excluding self-transitions, might have clarified some of this, because we were really hoping to be able to identify transitions that would symbolize that we knew what was happening well enough to actually intervene with the student. But the things that are being hypothesized and the mechanisms that underlie them are so infrequent that it's really difficult to operationalize any kinds of interventions at this point, right? So if it's not methodological differences, there could be population differences, there could be other statistical procedures that are required, but it may also be that our theoretical model needs revision. And I haven't quite gotten around to doing that yet, but I have some ideas that I'm going to talk about, right, in terms of what should a new theory consider, right? So rather than looking just at, what's the order of these things? Is the kid following this particular hypothesized model or the other version of it that's been sort of bandied around the literature? Maybe we ought to be looking at affect plus other information, right? Can we contextualize that information in a way that makes us better understand the affect? Because certainly what we know is that engaged concentration could mean that the kid is within their zone of proximal development and that they're being appropriately challenged. But it may also mean in some circumstances that the kid hasn't been challenged in a while. And certainly the data that we have from Liu et al. That shows that if confusion and frustration doesn't happen in those, those 3 clip sequences, that we don't see any learning. Would suggest that we should be pushing kids out of engaged concentration fairly frequently if we want to improve their learning. Right? Surprise is going to indicate that a knowledge gap was filled, but it also means that there was one there, right? So there's, sort of twofold information there about the difficulty that we can get out of that information. Delight could mean that we've fixed a knowledge gap, but it could just mean that we're working below the zone of proximal development, that we're not actually pushing the kid out, because it can be very pleasurable to work and not be interrupted by any kind of confusion or frustration. This is not to say that those things are always unpleasant, right? So we know that some students, if they're really engaged, actually really appreciate a challenge. And so we need to understand, when confusion and frustration mean that the child is being over-challenged, And when we need to acknowledge that, yes, they're being challenged, but they are still engaged, and that's really important information as well. We also need to look at boredom, because even though it appears to be sort of universally bad, it looks like it actually has two different meanings. So in some cases, boredom means that the kid is being over-challenged, but in some cases, it actually means that the child is not being challenged enough, right? So definitely, boredom is sort of particularly special, and it's one that I've been looking at the literature more generally outside of learning contexts to try to figure out what to do. If you look at the definitions of boredom, and this is actually from a visual thesaurus that I really like. The connotations of boredom have to do with fatigue. They might be related to sort of weariness or annoyances. But they can also be related to jadedness, right? So just a lack of a sense of wonder. So Dankert and Eastwood have gone through the boredom research on, in a lot of different contexts. And they say basically there's sort of three components to boredom. One of them is repetition without challenge, so monotony. One of them is there's not any value or meaning to the task. But the third one is constraint. So if you feel forced to do something, right, rather than it's something that you've chosen to do. These are sort of the three basic ingredients of boredom. And they can be present in different levels. But, I think it sort of rings true, and it's sort of the thing that we should be paying attention to. Is the child bored because they're not able to construct meaning out of it when they're over-challenged, or are they bored because they're being asked to repeat something over and over and over again after they've mastered it? Because those are two very different meanings, and they are likely to affect which affect the child sequences back into, but they also just need to be remediated in different ways. Right? These things also mean that boredom is probably culturally conditioned, right? So if you are dependent on being able to construct meaning out of the task, then your culture is likely to affect whether or not you can construct meaning out of that task. I think that there's probably similar things that we could think about, and I know you probably can't read all of the information out of the visual thesaurus here. It turns out, actually, if you try to put concentration into the visual thesaurus, you're much more likely to get things related to density. So this one here is for assiduousness, and we get things like diligence and effort that show up in this one. Confusion, you get things that are related to fogginess or haze, or discombobulation, but also to more basic mix-up. So like you've just inverted two things. So one is a complete inversion, right? One is I just don't even know where I should be looking at, and I think those are kind of two different experiences. But both confusion and frustration are probably really heavily tied. Well, in fact, all of these are probably really heavily tied to difficulty and effort. And if the kid is continuing to engage even through these experiences, we need to be paying attention to that. So we need to be looking at how long the kid has been suffering through confusion or enjoying the pleasurable frustration to be able to make meaning out of that. Right? There is clearly a lot of work to be done here, and again, I don't quite have the answers on how that's going to affect a new model. But I think that looking at these contextual pieces of information and whether or not, say, the kid is engaged during the first 5 minutes of class, or if they've returned to engage concentration after long periods of confusion and frustration at the end of class, will help us to better understand what these affect sequences mean and be able to develop better supports for students. Thank you all for having me. Thank you to people who have helped collaborate and provide data. and run analyses, and to our funders, and I will happily take any questions.